Wow, I can't wait to learn about stats today.
Hey guys, are you ready to discover the whole new world of skewness with just the minimum, the maximum, quartiles, median, and mean? Well, follow me! A distribution is symmetric if the mean and the median are equal to each other. However, if the right tail is longer than the left tail, then it is skewed to the right, and vice versa. In a skew distribution, the tail end values can be considered extreme values. As a measure of center, the mean is less resistant to extreme values than the median. Thus, you can determine the skewness of a distribution from just the mean and the median. Box plots show skewness along with the 5-number summary, which consists of the minimum, the first quartile, the median, the third quartile, and the maximum. In a left skewed distribution, most of the data is towards the right side of the plot. And in a right skewed distribution, most of the data is towards the left side of the plot. In a normal distribution, there's an equal amount of data both to the left and to the right side of the median.
Let's take an example from the AP test. Here, the 5-number summary is given. By using what we just learned, we can define a statistic that measures skewness. An easy way to do this is to find the distance from the quartiles to the median and then compare these values by making a ratio. You should be careful to avoid using the minimum and the maximum because there may be outliers. Our statistic will be greater than 1 if the data are right skewed. This means the median is farther away from quartile 3 and the data are more spread out on the right side of the graph. If the value were less than 1, it would be skewed to the left. If it were equal to 1, it would be normal. Another possible statistic that measures skewness is the ratio sample mean over sample median. If this ratio is equal to 1, the plot is normal. Similar to our other statistic, this value will be greater than 1 if it is right skewed because the mean will be pulled towards the longer tail of the graph. Likewise, the statistic will be less than 1 if the distribution is left skewed.
To demonstrate the usefulness of measuring skewness, we took a sample of 20 catmint flowers. By counting the number of individual flowers on each stem, we obtained data and used that data to find the 5-number summary.
The minimum is 2 and the maximum is 51, giving us a range of 49 flowers. The median is 40 and the quartiles are at 26 and 43.5, which means the interquartile range is 17.5 flowers. The mean at 33.2, however, was much lower than the median at 40.
This shows that the distribution is heavily skewed to the left, and we can use one of our previous formulas to prove it. When we plug in the data into the statistic, the value is less than 1, proving that, without a doubt, the distribution of flowers is certainly skewed to the left.